Good afternoon, everyone. Welcome to another live session at the Reactors. My name is Rav, and I'm the Program Manager at Reactor London. Before we get into the session, please take a moment to read our Code of Conduct. We're all here to learn, so please be respectful of other people's views, understanding of differences, and be kind and considerate in the way you engage. Today is the second episode of How to Use Azure to Kickstart Your DevOps Lifecycle series, and today's topic is Automate Container Deployments Using GitHub Actions. This session will be led by Liam, who is our Regional Cloud Advocate at Microsoft. The chat will be open throughout, and we do encourage you all to participate. And with that, I'm going to add Liam to the stream. Hey, Liam.
Oh, hello. It's nice to be here again. Right then, let me just share my screen and we will get going. I'm going to put some slides up. Hopefully you can all see that one. So let's get going. This is DevOps Series 1, Episode 2, and I'm going to be talking about GitHub integration. So continuous integration, continuous delivery, CI and CD. A quick agenda. I'm going to talk about me. I'm going to talk about the series. Recap on episode 1, which was last week, so last Tuesday. Going to talk about a bit about version control, what is CI/CD, because that's kind of the bulk of this one, and the project itself that I'm building. So, who am I? What do I do? My name is Liam Hampton. I'm a Microsoft Cloud Advocate, and I'm based here in London, in the UK, at the Reactor with the Reactor team. I'm an open source contributor, and prior to this, I was a software engineer writing Golang and Node.js. Through that, I've become an also technical blogger where I write for their blog. And I do that on lots of things. I'm an IoT enthusiast and, of course, a public speaker. So what is this series about? What am I talking to you about over the course of February? There's two main goals. Goal number 1 is for you to all understand the DevOps lifecycle, the processes involved, and understand how automation really works. That is the main goal of this one today. And the second goal is to put lessons into practice. So whatever you take away from this, and I've noticed there's a couple of you which have tagged me on Twitter. Thank you very much. It is brilliant because it shows me that you are learning something, you are taking part, and it is being fun for you. So episode 1, which was last week, that was the fundamentals of DevOps. So we created an application in Golang and we deployed it to Azure. So we sort of Dockerized it and put it into the container registry and then into app services. And we'll sort of recap on that in a second. Episode number 2, hello, this is us today. We're introducing CI/CD, which is automating some of the main or the manual steps that were in episode number 1. If you haven't already, or if you haven't seen episode 1, if you're new today, then please do go back and catch up. It is all on YouTube, and Ralph will put that in the chat for you, or for the link for that YouTube video, should I say. Episode number 3 is an introduction to infrastructure as code. So we're going to take the bulk of episode 1 and 2, and we're going to see how can we automate the creation of resources in the cloud. So episode number 1 and 2, what is DevOps? Number 2, automation of the deployment, and number 3, automation of the creation of assets or resources. And then finally, at the end of this, we're going to be talking, or I'm going to release a Microsoft Cloud Skills Challenge for you. And there may or may not be a prize with that one. We'll see, won't we? So like I said, this is where we are today, and this is what we're going to get into. Before we do that, I just want to say, because I forgot to say this last week, you can do everything yourself. For students, if you're a student on this stream, or if you're watching on the replay, you can still use this link, aka.ms/A4S. And professionals, if you're a professional software engineer, business, whichever domain you're in, you can certainly do that as well yourself with a free account at that link there, azure.microsoft.com/free. You will get some trial credits, and you can take part and do all of this yourself. So a little recap. What did we touch on last week? We wrote some code, or I wrote some code, I walked you through it, and then we put it into an app service in the cloud. And that's kind of what it looks like. It is a welcome to Liam's world. It's my travel blog. It's what I'm going to be building with you throughout this series, and hopefully later on throughout the year as well. We containerized the Go code. So we used Docker to containerize it. We used a multi-layered image, if you can remember, and a multi-layer image made that Docker container super small. So if we were to get all that code and bundle it up into a package, it was going to be about 1 gigabyte. Took that down into about 10 to 15 megabytes. Secondly, we pushed that Docker image to the Azure Container Registry. So kind of like a private store, much like Docker Hub for container images. And then thirdly, we created an app service in Azure. And we did that using the container that was in Azure Container Registry. And then that's kind of how it came to be the website. It's deployed and running. We also looked at the 8 stages of the DevOps lifecycle. So plan, code, build, test, release, deploy, operate, and monitor. And of course, if you want to find out, we kind of went into overview of that last week, but if you want to find out a bit more, please do go and watch the replay from last week. We looked at technologies involved in each step of the cycle. And again, it was pretty overwhelming because there's so many, but we're going to break this down into a couple today. So let's get into this. Let's talk version control. What is version control? So version control essentially keeps track of all your changes in your project within a team using a log. It allows many people in your team to work on one single code base. And it doesn't even need to be in your team. It could be anywhere. Many people working on one asset, one code base. And thirdly, you can easily revert changes if something goes wrong. So I don't know how many of you, but I'm certainly guilty of this, where, I don't know, prior to really knowing and learning about version control, I was always saving my Word files or all of my code, like final, may, that kind of thing, so on. Version control helps keep track of all of that, so you can easily go back to steps or previous changes that you made. There's 2 main types of version control. You have centralized and distributed. Centralized, an example of this is Subversion, or acronymed SVN, is where you have a central server with a repository on it. So that server can be plonked next to a developer, and it would just be running maybe on-premise. It's just a centralized place. And of course, you have developer 1, 2, and 3. They have their copies, which they're just sort of editing on the upstream. Second to that, you have distributed. Now, distributed is where there's a remote server with a repository up in the cloud, potentially. But there's another layer of abstraction here. You have a local repo, which the developers can then work off of. So let's see what the pitfalls are here. And by the way, an example of this is Git and using GitHub as the tool, but we'll get into that in a second. What happens if you have an issue with a centralized system? Let's say your repository or your central server goes down. There's a power outage. Your developers may as well just go to the beach because there's nothing they can do. There's going to be sat there wondering or scratching their head waiting for this server to come straight back up again. However, with a distributed system like Git, if you have an issue with your repository, if that server goes down, let's take GitHub, for example, if there's ever an outage, it's totally fine because the developers will be working on a local repository. There's this one layer of abstraction at this point. So unfortunately, they don't get to go to the beach. They can still continue working. So as we're going to be focusing on Git in this episode, what is Git? Git is actually an open source distribution system, and there is no central connectivity. And what I really mean by that is you sort of install this, it's open source. You can use that on your local system and push your upstream or origin or whichever you want to call it up in the cloud. Or to be fair, you can even have your own local Git server, but it's, like I said, recommended to have it so you have that layer of abstraction, kind of taking all that responsibility and liability away from you. It is super powerful. And I want to say that with great caution because you can do some really damaging things with Git. Like I said, if you have multiple copies of your Word document and you save it final, and so forth, you can easily jump back into that and just disregard the rest of them. Whereas with Git, you're kind of working off one main sort of long line of changes, which you'll then have to go back and revert to each time if you want to go back in time and look at the history. It is super powerful because you can then mess up anything going forward. It's a dangerous game to play, but it's also very, very good. It is very, very useful for a developer. And there's an emphasis on branching. Now, there's a lot on the slide here, but essentially a branch is a pointer to your commits. So when you want to make a change, a branch or that change should be used on a branch or should happen on a branch. The default branch name is main. It used to be master, but over the past year, it's all changed to main. And to be honest with you, it makes a lot more sense to be called main, and you should never be developing on your main branch. You should always use branches, so feature branches, should I say, and then you push them into your main branch. They have CRUD functionality. You can create a branch, you can read from a branch, you can update a branch, and you can delete a branch. CRUD functionality on branches. They're super cheap, super useful for developers. And of course, merging is pretty simple. Once you've made your feature branch change, you can then make a pull request and say, hey, I've got this change. I now want to put this into the main repository. And you can do that with a simple pull request. And finally, there's conventional commit standard. So when you do your commits, there is actually something called the conventional commits. And this will help you sort of establish what's going on. It will kind of organize your repository a little bit better. It stops you just saying update file, update README, those sort of things. It stops you from doing that. You might see some with emojis or emoticons, whichever you want to call them. But this one uses a pretty flat level commit standard. Feel free to go check that one out. But that's just a whistle-stop tour of Git and what Git is as a tool. So let's talk about GitHub quickly. What is GitHub? If you go to GitHub and you have your own profile, it may look something like this. This is mine, for example. You have a lovely README. It's a personal brand. You can follow people. It's like a social network for coding. Git is essentially a platform to host your Git code repositories. That is what it is at its core. It makes Git social. Like I just said, it's a personal brand, a way of having a personal brand for you. But if you're an organization or a team, it is actually dubbed the home of open source. Now, of course, you have other alternatives such as GitLab, you've got Bitbucket and so forth. There's lots going on there. However, GitHub is seemingly dubbed the home of open source. So let's look at some features. It's free to an extent. It's not always free because there is a paid tier, much like every other sort of service. There's always, well, more often than not, there's always a paid service that goes along it if you want extra features. However, I don't pay for that. I don't even get it with work. I seemingly just use the free option and I get all the repositories I could ever want, issues, tickets, projects, so much for free. Secondly, the code repositories. You can have issues. You can create releases. You can have GitHub Actions, and we're going to come to that one in a minute because that's what we're doing today. Kanban boards for your projects. So it makes agile development super, super simple. It really helps you organize your team in that way. And of course, like I've just reiterated again, personal branding. It is great to show yourself off. However, there are some don'ts with GitHub, and you don't push built binaries. Binaries, if you are building an asset, should be done with a release. A built binary could be dangerous. You could have packaged up something, stick it in your repository. Somebody else could then go and pull that down onto their machine. They then have a built binary, which you've created on their machine. And let's be honest, I wouldn't feel comfortable doing that. So you should never really push binaries to your Git repository. You use it as a release so people can optionally download that if they want. Secondly, you should never push slides. I would never put this slide deck up in GitHub purely because it's big, it's clunky, it's not going to load well. You shouldn't really use it for slides. There's other better sort of products to use for documents like this. And thirdly, API keys. Just on the touch of security, as I said in my first episode, hammering home security, never push API keys. That's your access token to pretty much your resources. You don't really want to do anything there. So let's look at CI/CD because, again, this is CI/CD episode. What does it mean? Continuous integration, continuous deployment, or continuous delivery. It depends which way you want to sway that one. I did actually answer this question at the end of my first episode. The difference between continuous deployment and delivery is one has more of a manual touch to it, whereas the other one relies more on the automation and the tooling. But we can delve into that at another time. It's often called a pipeline, and you'll hear this term thrown around quite a lot. And that is because it starts at the build stage, but it actually encapsulates lots of different steps. So it starts here at build, but you can test, you can create a release, and then you can push it to the deployment with a webhook and so forth. So it kind of encapsulates half of the cycle just in a simple pipeline. and you can do quite a lot with them. So why would you want to use CI and CD? Of course, speed. Speed in multiple contexts. Speed of delivery for your product and your customers. Speed of testing. Speed in the environment to have many more pull requests going through, many more iterations of your sprint going through. Speed in multiple contexts here. It is just all round helps your team with efficiency. Secondly, test reliability. Our tests or our code base is only as strong as our weakest test. Your tests need to be reliable. So a CI/CD pipeline is a perfect way to test with whether your test code is reliable in different environments. It may work locally on a machine, but will it work in a different environment in the cloud or in your pipeline? I don't know, you may be developing on Mac, but you may be testing on a Windows environment in cloud. Faster MTTR, mean time to resolution. So let's say you found a bug in your pipeline. Without a pipeline, that may have gone straight through because that may not have been tested locally. So mean time to resolution is how fast can we find that bug to how fast is it fixed. So that's that mean time to resolution, and it really does help speed it up. It helps create a smaller backlog because it's faster. The more you get done, the smaller chunks that are going through this pipeline, the more that's going into production, helps create a smaller backlog, and it's constantly speeding up that delivery process. And finally, the build environment flexibility. Like I just mentioned, you can be developing on a Mac or a Windows machine locally, but you could be testing in a Linux or Solaris machine up in the cloud. And that actually brings me on to a really good point. If you are going to be testing on arbitrary systems, such as Solaris, I don't have a Solaris box next to me. I also don't have a load of virtual machines with Linux or different flavors of Linux that I may want to test on. However, with containers, I can do just that in a pipeline. Containers are disposable. They're super cheap and they're great and they're stateless. You wouldn't store information in them. You just bring them up and dispose of them. But when you bring them up, you can run your pipeline code through them and see how it behaves in different ways. You can manipulate it quite well. So the build environment flexibility is fantastic in a CI/CD pipeline. And of course, let's look at some tooling. Now on here, you may see some familiar logos. You've got GitHub for GitHub Actions. You've got Jenkins. You have Travis, and I wholesomely apologize for the really poor text on there. That should have been white. You have Jenkins X and Argo. So there are so many on there. Just ignore the developer advocate in the bottom right. So yeah, there's so many different tools out there. And there's so many more that I haven't mentioned. But how do I choose them? How do you say, I need this tool for my job? Well, there's a couple that you can go through at this point. I personally look at these categories. So I look at whether it's open source. What are the built-in features? Where is it hosted? Is it going to be hosted on-premise? Is it going to be hosted in the cloud? Are we going to be hosting it in both areas? How much does it cost? Is it free? Do you have certain free runs for open source repositories, or do you start charging once you've, for a private repository, will you start getting charged for X amount of runs with a number of workers running your code, so concurrent builds and things like that? So where does the cost come into it? And what operating systems are supported within them? So of course you can bring in containers, but what else? Maybe you're not running everything in a container. Not everything does run on a container. You have virtual machines. You've got different resources being used in the cloud now, besides containers. So let's talk about the project. What are we doing today? What are we going to be playing with? Well, as I've said, we have a website that looks something like this. Welcome to Liam's world. Pretty boring. It's just got a title and an image. Let's visit India. I haven't added anything else. This is India. I want to add Dubai and the USA. So we're going to be changing that today. How do I make a change? How do I automate it? Well, again, I'm going to be writing the code. You're going to have to build, tag, and push the new Docker image to the container registry and restart the app service. However, if I was to do that manually, that takes a lot of time. I don't want to be doing that manually. I want to do it automatically. So automation for the win. I'm going to look back at my categories. Open source. Do I want it to be open source? Yes, I do. I want an open source project because I want everyone to use this. I don't necessarily want to pay for that. That sort of heightens the barriers to entry already if it's not. So I want an open source project. I want really basic features because we don't have an extensive application. We have got a basic Go app. So basically, I need to build a Go app. I need to build a binary. I need to run some tests against my application. I need to build a Docker image and push a Docker image. For a pipeline, that's pretty basic features, and that should be standard across the board. So where are we? Third, hosting. I want it to be in the cloud. I don't want it to be on premise. I do not have a server sat next to me. I don't want any of that overhead. I want it to be in the cloud, and I want it to be cheap. So I want it to be, I say cheap, I want it to be free. Okay, I don't want to be paying anything for this because I want you to try it as well. And I obviously don't want to be promoting a paid for service here. I want it to be open and low barriers to entry everywhere. And of course, with the supported operating systems, I actually want it to be Windows or Linux. So I just want to see what environments can hold those two operating systems for me. Because in Azure, my app service is actually running on a Linux box. So that's what I want. So I'm going to write some code. I'm going to push it to GitHub. Once I've pushed it to GitHub, it's going to run a GitHub action. It's going to build, test, and deploy that application, or that container, to Azure Container Registry, which is then going to have a webhook attached to it to say, hey, I've got a change. Go and update the app service. And you should hopefully see the change. So with that being said, I will jump out of this one and we can go and look at some code, because that is actually bang on 20 minutes and I'll try not to keep anybody any longer with boring slides. Rav, do we have any questions while I just quickly set this up? I can't hear you, Rav.
Sorry, I was on mute. So we have a question from Roween, and they have asked, do I need to see episode 1 in order to participate in this session?
Participate? Probably not. I would advise seeing episode 1 though, because it does give you the background of everything that we are going to be covering. I will, of course, do a run through and show you exactly what was done in episode 1. So no, I wouldn't say it's detrimental, but if you want to take part, we will give the link at the end for the repository. You can fork the repository or copy the code or do whatever you like with it. It's all public, it's all free. And of course, we'll have the links ready for you at the end.
And then we have another question from Fuel Snable, and they ask, is it Web3?
No, it is not Web3. This is not Web3. We will not be doing anything with the blockchain here.
And then we have not a question, but a comment from Cyrus. He or she says, if you see anybody in the VS Code team, hug them and tell them that they are doing a really great job.
I will certainly do that. We do have VS Code Day coming up soon, I think. So look forward to all of these wonderful things. Yes, VS Code is a fantastic editing tool for all developers. It is the dream, as far as I'm concerned.
And then we have some really nice comments from Fancy Bananas. They said, this is not boring, super informative. Nice work, Liam. And then we have another question from Gunny Devs. Why web app for containers over container instances?
That is a really good question. And a really good way to answer that is because I'm using Go. And with that web apps, it's a serverless service, I believe. That means that I can scale it up and down as much as I like. Second to that, I just like app services. I'm using Go. I want to containerize it. We don't have a build pack in Azure for Go. So put it into a container, throw it up in an app service and scale it how I like. You can also add a sort of a link to it. So your own URL, so a domain name, so many more things you can do. It's personal preference, I think. I just like app services. They're fun to work with.
We have another question from Cyrus Z. How come GitHub Action don't have so that you can deploy to Google Cloud? There are all kinds of stuffs on Marketplace, but not for Google Cloud.
That is a great question. And to be honest with you, I really don't know. That is all I can say for that one. I guess if you really want to, well, if you really want one, maybe you can try and ping someone from Google because, yeah, it's open source. I'm sure you can probably make one as well. Again, I don't know the answer to that one, unfortunately. We're just going to be dealing with Azure Cloud today.
Don't think you can scale on a free tier, can you?
I don't think you can scale much, but for what we're doing today, it's absolutely perfect for what we need. And of course, if you have a free trial, you have credits, you can scale up and down.
Great. Thanks.
Right,
I think that's all the questions.
fantastic.
Oh, sorry, we have another question if you're okay with.
Yep, got one more minute.
Azure Devops also provides a free build time board, Git repo, and features that you have described GitHub. Would you provide a pros or cons of one over the other?
Certainly, but not right now. I will come back to that question at the end because I would like to think about some of them. Personally, I have a couple, but I'd like to come back at the end because I want to get into the code so I can show everybody what's going on, if that's all right. Great questions, and I love it. Love the interaction. Right. So I think, Rav, you need to go on mute, otherwise we're going to get a bit of echo. There we go. Fantastic. Okay, so the very first thing that I actually want to do here is I want to prepare my app service to take a webhook, take a change. So when I make a change, it should update automatically. So the first thing I'm going to do is by having a quick look at what we have. So last week we created an application. It was in app services, and here it is. If I go over to the URL, which is Liam's World website.azurewebsites.net, you will get this here. So there's nothing much going on. I can scroll up and down as needed, but there's nothing there. So the very first thing I want to do is create a webhook. Now, a webhook is going to, like I said, allow me to update on the fly, so I don't need to restart anything. And to do that in app services, there's a really cool little configuration. If I go into Deployment Center here on the left, I can scroll a little bit down to the bottom. So as you can see in here, this is all our configuration. So container registry, using a single container, Azure Container Registry where it's stored, my subscription, and I've got some admin credentials so I can manipulate the container registry as I please. The name of the image, so on and so forth. But this is the interesting one here, continuous deployment. If I click that to be on and I click save, that should update the publishing, the user credentials and the application itself. So if this has worked, and I hope it does, we can go into the DevOps on Azure Container Registry and we can look at some webhooks. And here it has already created a webhook for me, Liam's web app. So this is the container registry storing my container. So we can have a little look at the repository in here. We'll see DOA-EP1, which is DevOps on Azure episode 1. In here, we've got the tag v1 and, of course, the 3 layers of my image, which I've created. So we have a webhook. Perfect. Now let's have a look at some of the code that we changed last week. So we can just come out of this one, and hopefully I should have it open here. Let's use my actual mouse as opposed to trackpad. Okay, so we have a main.go file. So again, the purpose of this is not to teach you Go, but to give you an understanding of what it kind of looks like when you're creating a server. So we have some handlebar templating. We have a Go server. It's called a Fiber. And the reason I've chosen Fiber is because it looks the most similar to Node Express. As some of you may see, we've got app.get, very, very similar, takes in a root and then a function, which I'm calling here, and it's just returning or rendering the index.hbs, which is a handlebars template. It's just HTML. As you can see, I have my section, which is India. I'm going to make some changes. I'm going to add Dubai, and I'm going to add the USA. So I've got a couple more changes, but we'll do that in a moment. The main HBS is my main handlebars template. Again, this is just the main document, so doc type HTML. I haven't really bothered with the style sheet. I know it says it's over here, but I haven't really bothered with it because there isn't that much styling in there. The body is just encapsulating a header, a footer, and embedded is just taking the main bulk of the index HBS and embedding it into the body. So I can just take this div tag or this section, should I say, or this main div, and plugging it into the body. So that's a whistle-stop tour of what we did last week with the code. Now, the Docker file is actually what I built last week. And just as a recap, so if anybody that is here that wasn't here last week, I created a multi-layer image. Now, the main image that I'm going to be building, or that I built the application from, was Golang 1.17. It's using that because that's what I'm using locally. So I always want to stay consistent. I'm going to be using Alpine 3.15, which is like a good version of Alpine, one of the latest, I think. And the key here is to say as build. I'm going to set the working directory as home. I've copied across a bunch of files, so my mod file and my sum file, so all of my dependencies. I've done a download on that. I've created the views templating just as I would here in my main layout, or my main folder layout, should I say. I've copied across everything that I need, built the binary with this wonderful line here, called it website. So I've chosen the operating system, the architecture, and I'm saying go build, removing some debug flags, and a bunch of other things inside the binary that I just don't need, and called it website. I've changed the access permissions, and that was what I did at this point. So I have a binary. Now, the final thing that I did was create an Alpine image called from Alpine 3.15. So again, staying consistent with the main image. I copied the file from before, so the website binary over, and the views folder over from the previous image that I built. And I chose that because everything inside views is going to give us the styling, the templating, everything that I actually want to see on the page. And then I'm just exposing a port to say, hey, this is my exposed port 3000, and the entry point on this is website. Now, of course, you can use CMD. They're very similar, very subtle differences. That's a topic for a different stream because that's a deep dive on containers and how they work. But that is essentially what we did. Now, I didn't do one crucial thing last week, and I didn't push this to GitHub. So I'm going to open up a new terminal, and I am just going to say git status, if I could type. Now that's going to say I have got a file, modified Docker file that I haven't pushed. So we're going to do a git add, and I'm going to say Docker file. Now you can do a dot or a period, and that will just do everything. If you have multiple files, it'll do everything to stop you from adding them one by one. Again, like I said, pretty dangerous. It's a shorthand, but you wouldn't, I use it as a shortcut only when I know what I'm committing doesn't need to be pulled out and is safe in the history. So if I do git status again, so again, these are just very basic commands in Git. But again, if you want to see more of a deep dive on Git, please throw it in the chat because the more the merrier. Anything else like that will help or let me understand what will help you as developers. So there you go, it's gone green. So it's added. So now I just need to do git commit. And again, I need to give it a good commit message. So at this point, I'm going to say add Docker file here. So we can tell straight away I've added a Docker file in this commit. Wonderful. So now it's committed. All I have to do is git push origin, because in fact, let's go back. I'll show you why I'm doing origin. So git remote -v will give us the origin, which is my repository where I'm pushing and fetching from. So pulling changes from and pushing changes to is up there. So we can do a git push origin, and I'm going to be really naughty and do main because I know this isn't going to do anything harmful. Famous last words, right? So we're going to push that up to main. Wonderful. So now we don't actually need this terminal for 5 minutes. We've got everything up in GitHub. It's all up to date. We have a Docker file. Should work nicely. So what are we doing with GitHub Actions? Let's get into the meat of it. We are going to, I closed that terminal, I shouldn't have. We're going to create a new directory. And I'm going to do, which is make directory. I'm going to get a -p, so there's, I think, kind of recursion in there. I'm going to call it .github / workflows. And that's going to say create a folder called .github and create another folder inside called /workflows. So if I press enter, here we go. We should see it over here, and workflows is in there. So now I can just go into it. So let's go into GitHub and go into workflows folder, and we do path. We can see that's where we are now. I want to create a file in here called deployment.yaml. So I'm going to do a touch and then deployment.yaml, and that's going to create a new file called in here. So we can just minimize all the other noise and open it up. So this is going to be our main deployment file for GitHub Actions. So when I push this up, it should bring it down or know what's going on. When I push this to GitHub, GitHub should recognize this as an action because it is in a sort of reserved name repository, should we say, or folder directory. That's probably a better way to put it. Okay, so in here, we are going to want to create the workflow. So let's give it a name. So the first thing I want to do is give it a name, and I'm going to say, let's give it let's do this properly. Build a Docker image and push it to ACR. So build a Docker image and push it to Azure Container Registry. Okay, the next step we want to do is say, when is this going to do it? What action is going to kick off this workflow? So I'm going to say on, and then we're going to do underline, we're going to do a push. So on a push, and then I'm going to specify the branches that I'm pushing to. Now, please don't worry about these sort of hovers or these errors. It just doesn't like some certain things going on in here. But that will all clear itself up when we finish the file properly. So in here, I'm going to do main. So I'm going to specify my main branch. So on push of the main branch, and we're going to come down again. And let's go back. We want to do a workflow dispatch. Now, this is a bit of an odd one to have in here, but there's a reason for it. And the reason I've got that in here, let's do that properly so it's under there, so it's in the right place. This will allow me to deploy it manually. So if I want to go into my actions in the GUI, which I'll show you in a minute, I will then be able to click a button and say, run this workflow manually for me. It gives me like an option to force it in a way. Okay, next we want to look at some environment variables that we may have in here. So if I think about what I'm going to be doing, I didn't actually specify branches down here. That's why it's complaining. Sorry about that one. No, it's doing something weird. There we go, main. There we go, that's better. So in here, we're going to have environment variables. What environment variables am I going to be looking at plugging in? We are going to be looking at the tag of the image. Now, this just helps you kind of not have to hard code so many values inside your workflow. So let's do tag, and we're going to say that's going to be v1 because we want it to be version 1. We want to keep it consistent. What else are we going to have? We're going to have server. That's right. And at this point, I'm going to call it DevOps on Azure -Azure cr.io. So I actually have this in a file, so I don't have to go digging for it, but you can dig for this inside the portal. It just helps with context switching here. I don't want to be jumping around too much. So that's the server name. That's what we're pushing to. And the image is the other tag that we're going to want. So it's going to be like the image name. And at this point, we're just going to say DevOps on Azure, and we're going to say EP1. So those are my environment variables that I'm going to be plugging into this workflow as we go. What do we got to do next? We need to specify the job. So what's actually going to happen? What do we want this workflow to do? So we create a jobs. We're going to say under jobs, we want to do a build. And within this build, I want it to run on. So we're going to do runs on. As you can see, it's already trying to pre-complete things for me, but I want to type it out properly. I want to run this on a Ubuntu image. So I'm going to say Ubuntu. Yeah, I really am not very good at typing today. But we've got Ubuntu latest. So that's going to be the base image for my pipeline. So remember, if we go back to my presentation, we're choosing the operating system. I'm choosing Linux in this instance. Underneath here, underneath runs on, we're going to have some steps. And inside the steps, we are going to we want, again, inside this step, it's going to be like a containerized or packaged up environment. We're going to say this one uses, and we're going to say actions/checkout at v2. And that just means that we're going to be using the actions version 2. That's what it's saying. Use that version of GitHub Actions. Cool. So now we want to look at the name of this step. So what's the first step we want to do? Everybody, the first step we want to do is set up the Go environment. So let's just say set up Go. There we go. And we can say this one uses actions/setup Go, because there is a predefined action which will set up a environment, allowing me to run some Go code. So we're going to do setup-Go. And again, we're going to do version 2 at v2. Again, it's just trying to do some pre-completion for me. I don't want to do that because that's when things go ski-whiff in demos. And I'm going to say with what version. So this is where I specify some parameters. So it's at this point, I'm going to say I want it to be Go version. And again, I always make sure I do these colons because as we proved last week, I always forget the colon. And I'm going to say 1.17. And that is because I'm using that. I'm keeping consistent with the image. I'm keeping consistent with my local environment. I kind of want it to replicate what I've already got going on. So what do we do after that? We're going to have a test. So remember, we built a test file, and that test file over here, main._test, is testing that we have a bunch of files in the root directory. So, and again, I always forget this one. So I'm going to say, why is that not liking Go version 17? Oh, there we go. God, YAML is fussy, isn't it, everybody? Okay, then. So down here, we're going to have another stage or another step, and we're going to call this one test. And in the test stage, we're just going to run a command, and this command is simply going to be go test -v, and then it's // and triple dots. And what that's going to do is it's going to find every test file. We admittedly only have one test file, but it's going to find it in our root, or in our, the root directory, and it's going to pull it out and run it. That's what we need it to do. Otherwise, you can specify, you could just leave this as -v if you want, but again, that's just a go. That's go. We don't need to worry about that one. That's another stream in itself. I'm always very good at getting pulled into those kind of things. So what do we want to do next? Okay, so let's assume that our test passes. So we've set up the Go environment, we've tested our code. Now we actually want to use Docker. We want to use Docker to build our container and push it to the registry. So at this point, we want to say users. And again, this is just specifying what action we want to do in this step. And we're going to say Azure/Docker login, because we're going to need to pass it some credentials at this point. And I'll come to you how we're going to do that in a moment. But I'm going to use version 1 at this point. And I'm going to say this is with, and now here's my parameters, my bunch of things that I want to put in. So we're going to say login server, which is going to be, we've already got it up here, haven't we? So if we have a little look, it's an environment variable. So our login server is DevOps on Azure, period, Azure cr.io, or period, whichever one you want to call it. So this is how we add in an environment variable. We're going to do a $, and then we're going to do 2 curly braces. And at this point, I'm going to say env to specify I want to grab the environment variable that I set at the top. And then I'm going to say server. That is all I need to do. So the login server is my environment variable. Next, I'm going to need a username. Now, this is a fun one. I'm going to leave this one blank. And password, I'm also going to leave this one blank. I'm going to do this for a very good reason, because I need to fill it in a moment. So that is all we need to do is log in to Docker. So log into the registry using the Docker engine. I presume that's in GitHub itself in the action, which we're using. And we want to then run some commands. So let's go back. I want to run that one. And I'm not very good at that one today, am I? So we want to do a pipe, because I'm going to be running 2 current commands here. I'm going to say Docker, and I'm going to do a build at this point, and a tag. And this tag is what I want to call the image. So remember last time in my previous episode, we did a build of the main image, Docker file. We then had to tag it with what we wanted to, and then we went to push it. I'm going to remove that first and second one and just concatenate them into one. And I'm going to call it. And I'm going to call these the environment variables. I'm just doing one line. So I'm going to do Docker build period. That's going to find the Docker file in my current directory. I am then going to say env.server. And after that, I'm going to have a /, and then I'm going to do another one. And I'm going to want it to be let's do a space, env.image, like so. And then I'm going to want to give it a tag. So after this is just creating one big string with just inputted data from an environment variable. So it really isn't too difficult to do. And it makes it super simple having environment variables available to you. So we're going to do that one, and then we're going to have the tag. That's what we need to do for that command. Now, the second command I want to do is obviously the Docker push. And we're essentially just going to be pushing the above image. So we just need to do a Docker push. And then what I can do is I can grab this one, and by all means, copy and paste is probably going to be the devil of me one day, but we will just plug that one in there and push it to the environments that we want to. So in this instance, the logged in container registry. So it is at this point, I want to draw our attention to username and password. Now, the reason I want to do that is because they're going to be secrets. We do not want to expose these in the Git repository. Going back to the presentation, we do not want to have API keys or anything like that inside our inside our application, especially not in Git or GitHub, because that's public. Everyone can see that regardless. There's tools to stop it, but we don't want to do that. So how do we add the secrets in? What I'm going to do is I'm going to save that file, and I am going to go to the portal. So inside the portal, we can go to the container registries, and we can look at, where are we? DevOps on Azure. Let's look at access keys. And you can see here we have a username and a password. And for anybody watching this on replay, this does not exist anymore. I will have regenerated these. So let's go into GitHub itself. Now, this is going to be on the repository. If we look in here, we have actions. Like I said, we haven't actually got anything. We could add this manually if we wanted to, but I wanted to create it properly for you with some code. Let's go into the settings. And in the settings, we're going to add in some secrets. So we go down on the left-hand side, we're going to hit secrets and click on actions. Inside here, you can see I do not have anything. So I'm going to create a new repository secret. Let's call this ACR username. And the username is going to be this one here. So we're going to copy that to our clipboard and going to plug this value in here, DevOps on Azure. And we're going to add that secret. And again, we want to do the same thing, but this time we want to do it with a password. So again, we're going to grab one of those. And because I've got admin rights to this container, and I will be regenning those in a moment, so please don't copy them, we will add these secrets in. So what that means now is I can reference these secrets inside my file. So if we go to the code, let's open it up again. It's over here, that one. I can then do, very much like we've done with the environment variable, so m.server, we can do a $, open some curly braces, and do secrets dot ACR underscore username. That is how we reference a secret in GitHub. And again, we can just copy this one and drop it in the line below and call it, you guessed it, ACR password. So that is our pipeline built and ready to go. So what do we want to do? Let's throw that up into GitHub, shall we? Let's push that up. And hopefully, if I open up, oh, for some reason that doesn't want to open up a terminal. There we go. Let's just make sure that's saved because that don't know why that was doing that. Cool. Let's actually run through it one more time before we do this. So we've got a name. We have on. It's going to on the push of the main branch. We're going to allow a workflow dispatch. We can do it manually. We've got some environment variables. So server, DevOps on Azure, image, DOA-EP1. And the job, we're going to have a build. And in that build, we're going to run on Ubuntu. So the main overarching image is going to be Ubuntu. It's going to have a number of steps. And we're going to say it uses checkout version 2. And we're going to set up a Go environment of 1.17. We're going to do some tests of our local repository. And we are then going to, if they pass, we're going to build an image and push that image to the container registry in Azure. So let's open up a terminal. And again, if we do git status, we can see that we have added .github. And hopefully, yep, that looks about right. So we can do a git add, a git commit, and inside here, add a deployment workflow. Push that to the main branch. And we can go and check out GitHub now. So hopefully that would have all gone through. If we look up here, we should see, there we go, an action has appeared. And this is going to run through everything that we've done. So we can actually go and check it out at this point. We can see what's going on. So if we jump into build, we can see that it's set up the Go environment. The tests are running. And you can see all of the output here. It's just like a terminal. It's pulling in some of my dependencies that I need for my testing. So it's going to be compiling the code. Of course, you could do this with a binary, make it much quicker, but I wanted to show it fully fledged with all of the modules, give it a bit of time to pass. There we go. We can see it's passing. It is logging in. It's pulled the image. It's going to be deploying it. It's going to be building it. It looks like it's all okay. So give it a few moments. I really hope this passes now. But we can go check this out in the container registry once it's pushed. And these do take a moment, but it is certainly worth it with bigger teams when you've got quite a lot to do. Again, this is going to take a moment because it's doing the downloads. And this is exactly why, and I think I showed this in my first episode, when you build the image, because it's multi-layered, it needed to do a lot of downloading. It needs to do a lot of, it kind of bloated it out quite big, which made it about 1 gigabyte. So then we created obviously the second layer, which was a smaller image of about 3 layers. There we go. We've built the binary. It should be running to create a second image any second. And once this is done, push it up and we can go and check it out. Here we go. It's on step 10. Lovely. So it's pushed everything or pulled everything. It's copied it across and hopefully, fantastic. It can see that our build has, what I say, has passed, should pass. Fabulous. As you can see, it's doing just a SHA checksum on it. There we go. It realized there was some in there. Our build has completed. That is our action. It has thrown it into the container registry. So if I go and look at the repository in my container registry, so over here, click on DevOps in Azure version 1, we can see here at 4:51, today's date, that is when we last updated it. Amazing, right? So what is the whole point of this? What are we going to do next? And I know I've only got 10 minutes. I'm very conscious of time because I want to answer some questions. But let's close this. Let's go and add in a couple of things to my webpage to make it look better. Let's make it look better. It looks boring right now. So let's add in a few more. So what I've got here is I've got 2 more sections. One is going to be Dubai. One is going to be the USA. I've traveled to both of them. I've got some good pictures on both of them. And hopefully it's going to look good here. I don't think I need to do anything else. I've already got the styling. So just for context, if I look at my styling, what it's going to do is going to be a gradient overlay of some RGBA colors. It's just going to be like a grayed out. So it's not a raw image. I'm pulling my image from Imager because that's where I host them. Now, that's a really good thing that's just brought to my attention. I should be using blob storage at this point, or something like that, object storage. That was going to be another stream at another point, but I'm just storing it in Imager for now. And as you can see, I've made a change. You can see it's M for modified. If I save that file, make sure everything is saved correctly. Let's go and push that change up to GitHub, shall we? So again, we can do a git add, and I'm going to add everything because it's just one file. I'm going to do a git commit, and I'm going to give it a commit message of adding Dubai and, that's how you spell it, I think, yep, and USA sections to the homepage. Don't worry about making these too short because the more verbose they are, the better, because it allows somebody to actually read what you're changing when they read through the Git log. So do a Git push. I'm going to push to origin and I'm going to push to my main branch. Again, I should probably be creating a feature branch here, but this is just a shorthand in the essence of time. So if I push this to my main branch, go back to GitHub, hopefully we'll see another workflow that's kicked off. So if I go back to my actions, we can just see another workflow that's kicked off. Now, again, these can be kicked off at any point. These are just triggers, webhooks essentially in GitHub, which allows us to do all sorts of things at this point. Give it a moment to load. I think actually, because we have only a couple minutes left, I might take some questions while this is running. Rav, do we have any questions in the chat?
Yes, we have. So where were we? I think you're meant to get back to Andres about the Azure Devops provides free build time, and going down.
In fact, let me do that one first, actually.
Yeah.
Well, I should pull them out. So Azure Devops, if we scoot back to my first episode, if you've seen it, I do actually touch on Azure Devops as opposed to this way of doing it. Azure Devops is very much a service provided by Azure. Fantastic service. It allows the DevOps lifecycle to be simplified within within the Azure cloud itself. The reason I'm doing this way is because it allows me a little bit more freedom. I want to be able to pick and choose the technologies that I'm using. So I want to be using GitHub Actions as my build pipeline. I want to be using maybe ZenHub or let's say issues in my repository. I may not want to be keeping my repository in Azure repositories itself. I want to be using GitHub. It's where I'm most comfortable. Personal preference from that side. There are pros and cons to both of them. So being vendor or being inside a vendor such as Azure, you're obviously going to have great hook-ins to all the other Azure services with a little bit less of sort of playing around and massaging it. Whereas if you're using something like my workflow here, you'd have to do a little bit of massaging. You need to log into Azure. You need to make sure that you're authenticated when it comes to creating and pushing images, those sort of things. So it's very much down to what are your needs? What are you trying to get out of it? How simple do you need it to be? And if you're going to be sticking under one main umbrella, how long are you going to be there for? You need to really think about those sort of things. It's the same with most other things. You could easily use GitLab for all of this. GitLab, another fantastic tool, but I'm just choosing to use GitHub. So hopefully that answers it. Again, the services itself are just very, very much down to you. I'll tell you what, if you can just hold that question one more time, I'm just going to grab that. Hopefully this has worked. We should see a change in my website. Here we go. It worked. So earlier we couldn't scroll. Now we can scroll. And my title disappears. And I have a picture of me in Dubai. And I have a picture of me and my cousin in Florida Keys. So down very, very south. That's 90 miles from Cuba. We drove all the way down. But as you can see, I can add lots of different things. And it's all automated. So all I had to do was change the code in the repository locally on my machine. So again, I can just click on these tiles at the top. It will take me down, just a bit of nice styling. This is just the backbone of my portfolio website. But I really hope you have learned something here. I'm just going to grab up some slides because that is actually the end of the demo. I'm going to quickly jump in to here. So what have we done? We have made a local change, pushed the code to GitHub, created the action. It has run. It has deployed the app service automatically using the container registry. And we can talk about the next week's episode. And next week, we are going to be focusing on infrastructure as code, where we're going to be automating some infrastructure creation. So if you're around in the first episode, what I did was I manually created a app service. I had to go through the portal and choose everything, each individual part. I'm hopefully going to be able to automate that either with Terraform or Bicep or some ARM templates. I will be plugging one of them in. Stay tuned, and I really hope to see you next week. Thank you very much for watching. I really hope you learned something. If you want to join our meetup to see more of this, I will be doing so many more events here in the London Reactor, where you can see I am today. Please join meetup.com/Microsoft-Reactor-London. And my LinkedIn is Liam Conroy Hampton, just at the bottom there. So Liam-Conroy-Hampton. And my GitHub and Twitter username is exactly the same. It is Liam C. Hampton. And with that, I'm going to hand over to Rav and hopefully answer a bunch of questions.
Thanks, Liam. So we have another question from, it's actually from, it is a question. It says, does free tier in Azure stop services if I hit the budget, or will it turn into a paid tier? Sorry, Liam.
I just realized I'm on mute. Of course, I got the mute button on my, that is the first time I've ever done that. Yes, so in answer to that, I personally don't know because I have never really paid much attention to the pricing on the free tier. What I do know is that it is free for at least 60 minutes. So I can actually show you that. And hopefully, I would think there is a way to cap it. There is a way to stop it. I would assume there is. But again, I don't honestly know. I will have to find that out for you.
Then we have a question which says, why are you pushing directly to main? Wouldn't using a branch be safer?
100%. And that is exactly what I was trying to explain. Pushing to main was in the interest of time. I will probably be doing a basics of GitHub, of sort of coding, getting it into the cloud, using branches and feature branches properly. But again, the point of this workflow was to show it was automation working. Yes, you are 100% correct. And thank you for calling me out.
We have a very nice compliment from Kwesi. You're doing awesome, Liam. Then I just rewrote our Azure Devops releases to YAML pipelines. Oh, the pain. Then next question is how to deploy a container in VM through GitHub Action.
That is a really, really good question. And that is a whole stream by itself. So if you wanted to deploy a container through a virtual machine, you would obviously have to set up an environment in Azure, allowing you to do that. So very much like I ran a sort of a containerized sort of block of code in my pipeline, it would need to be more tailored towards that one. And I would probably say you're looking at more infrastructure as code at that point, because that's bringing up services as opposed to pushing to a service like I was. So it wouldn't be too far off what I've done. But again, that's probably going to be in my third episode. Please stick around because I will show something very similar.
How do you get the image tag without checking the logs?
The image tag of the container itself. Is that what you mean?
It just says, how do you get the image tag without? I think it was probably while you were coding and the question just came up.
So if you have a bit more context, if you throw a bit more context in there, as to sort of what you mean, I'll probably explain it.
Is there a way to see the image tag in GitHub instead of checking the ACR?
That is a very good question. Yes, there is. And I'm just going to try and find it. It'll be in the build logs. Let me just try and grab it up. Actually, I lie. I don't think you can. I think it's going to be where you are pushing to, where you're going to see the image tag. So like I said, in the container registry. Obviously, you'll be specifying that. No, sorry, GitHub Actions is just the tool. You won't be able to see that to my knowledge.
Okay, and then we just have more and more compliments. This was awesome, very informative. Thanks, Liam. Good day. Are ARM templates less or worse than CloudFormation?
Stick around for next week and I will show you. And I'll try and answer that then. I don't really have a preference. I think infrastructure as code is fantastic. ARM templates, obviously being Azure, and I think CloudFormation, if I'm corrected, it is AWS. Again, they're very much the same thing. Very, very similar. I mean, you just have to stick around to next week and I'll show you what ARM templates look like, I guess.
I think that's it, Liam. Just one more compliment from Dr. George. Excellent presentation.
Fantastic. Thank you ever so much, everybody. It's been fantastic. I really hope you learned something. And yeah, please do stick around for next week and we'll be touching on infrastructure as code.
Liam, while you're there, I'm just going to put the Learn module in the chats. So,
yep. And before I forget, the repository for this is one of my personal ones. I think, Rav, you do have a link for that. So if you could please pop that in as well, that'd be awesome.
Great, that's all done. Thank you very much, everyone, for joining us on this session, and we'll see you next week, same day, same time. Bye for now.
Thank you. Goodbye.